So, welcome everybody for the first talk of the last day. Today we'll be talking about packaging. And we are going to talk deeper about macros. We are going to compare a little bit about different approaches that distributions uses. So, I'm Danilo Spinella. I'm a research engineer in the Future Technologies team. And before moving to the Future Technologies team, I worked for the PAC team. And before doing that, I spent a couple of years working in my free time for a couple of distributions. I was there packaging and having fun. And this is also one of the reasons that I was so happy to join SUSE and continue doing packaging work for openSUSE and SUSE. So, first of all, we are going to see how packaging as a program work in, first of all, openSUSE, and then a couple of other distributions. We are going to do the same for Python. We are going to see a couple of caveats that we can find in the various approaches. And then we can see a couple of improvements that could be done to. So let's start with the RPM. RPM is the standard that we use at openSUSE, it's the one that Fedora uses, and many other distributions use RPM. This is a very simple package. I think that this is the simplest package that we can find. It is a C program that takes as an input a markdown file, and then it shows you a nice little presentation. Basically, it's just a couple of metadata inside RPM. We say that we need courses, package config, and then we use make build, make install, and list just 3 files, or 4. So it's very, very simple. You can see here that in RPM we have the metadata first, then the various phases described by the macros, and inside each phases we call macros most of the times, like make build, make install, and so on. And let's go deeper. So what happens when we have a macro like make build or make install? Macro is basically an expansion of text that RPM does during build time. So every time we have make build, then RPM replaces that with make and a couple of flags, the flags that we use for building all packages. And the same happens with make install. We call make again, which is another macro, yes. And you could make install, desdir, and install, and so on. And macros are recursive, so you can have macros that calls other macros indefinitely. You also need to be careful because otherwise there will be a Stack Overflow very, very soon. And this is the backend, basically, what happens behind RPM. And this is also an approach that is different between distributions because the macros that we have on openSUSE are different than the ones that are used at Fedora and so on. So let's describe what is an RPM spec. I think that we can just say that RPM spec is a collection of 3 different things: metadata, comments, and macros. This is how we build the package. This is how a package what a package does and what the package contains. Let's do a step back. Let's define what packaging is in general. And I think that we can just summarize that packaging is, for general approach, at least, not the one that openSUSE is taking, but all distributions are taking, is we collect metadata, sources, comments as well to build the package. And the last important thing is patches, because everybody has different patches. Everybody wants their package to behave maybe a little bit different than upstream. Maybe we need something that upstream doesn't like. So I think that patches is also a really important part of packaging. So today we are going to talk about 3 different distributions. The first one is Arch Linux. How many of you have used Arch Linux in the past? So I think a couple of yes. I see somebody. It's very, very famous, and it uses the keys principle, keep it simple, stupid. That's the approach they use. The second one is very, very niche. It's a fork of Gentoo made in 2009. And It's very particular, this is why I'm showing it in this presentation. Then the last one is Void Linux, which is pretty famous in the muscle libc-based distributions, along with Alpine. So let's start directly with a package build for Arch Linux of the same package that we saw, of MDP. You can see here that we have still the metadata as the first part. And the metadata here are bash variables. Everything here is bash variables, bash functions. This is how a package build is defined. And I think that's very interesting to see that the second part, which are the different phases, in this case just build and package. Package is the equivalent of install. We can see here that everything is called manually. We don't have a macro, we don't have a function for make, we just call make. And that is true for everything. We just call everything manually, maybe Python, cargo, and so on. This is a completely different approach because they want to keep it simple. They don't want to have any wrapper. Now let's go over to the MDP package for Exerbo. As you can see here, the copyright, I've written this package a couple of years ago when I was packaging for Exerbo. And here, we still have metadata written as bash variables. So all metadata here is summary, slot, platforms, everything is a bash variable. And the build phases are also bash variable, the bash function, sorry. So we can see src prepare, and we do some changes to the Makefile, we said. And there is nothing else. Where is the build phase? Where is the make install? This is why these kind of packages for Exerbo are very simple, because a lot of phases have a default value. So in this case, the default is always the Mac one. This is a Mac package. We don't need to redefine again the phases for building and installing. It will automatically call make install and make. So one thing that we missed before, let's go over to the file. There is no version here. There is no version because the version is inside the name file. Every file will have a different name compared to the, which refers to the version. It's very different approach. There are ways to avoid duplication of the code. So have multiple versions of the same package without duplicating the package itself. But the version is always in the name file. So we will have a bunch of files with different versions. And this is the default phases that I was speaking about. So we have the compile phase, which is by default is calling make with the default params. See here that is called emake instead of make, because emake is a wrapper around make. This approach here, instead of using macros to avoid duplication, they use bash functions. Emake is a bash function, so they call make with the default cflex and c6 flex. Then we have the install. The install will check if there is a Makefile or a GNU Makefile, and if it is, then it will call make install. Otherwise, you say, okay, I don't know what to do. I won't do anything. Very simple approach. This avoids the duplication, and it's also very similar to the next one that we are going to see. This, again, is another package. It's a package for Void Linux, still MDP. And this is just metadata here. This is the entire package. There is nothing else. It's very simple. I've taken it from, they're called template files. And I've taken it from Void Linux repository. And this is still a bash file, bash script. Everything here are bash variables, the package name, and so on. And we don't see any build phase. We don't see any make install, make. That is very particular of Void Linux. They use a build style variable. And in the build style, they define what kind of build they're doing. In this case, it's a GNU Makefile. And by just saying that we are using a GNU Makefile, then there will be another script with the different phases that it's here. For example, this is the do build. Every time we say build style, and it's GNU Makefile. This is the part that would be called. This is a bash function that would be called for the build phase. It's make, and you just pass all the default variables. It's calling just the build args, build target, and so on, but it's just a make with configuration around it. And this is very powerful because we don't need to define phases for everything. We can just say, OK, this package is getting built by using cargo. Then we have a build style cargo. And we don't need to write everything everywhere. So we are seeing 4 different approaches. The RPM macros that we are very, very, very familiar with. The approach taken by Arch Linux, which is just the simplest one that I can think of. Then we are seeing Xturbo with little bit wrappers around that, more flexible, but also a little bit verbose. And then we saw template files, which is just that we need to define what kind of package we're building. We can override, of course. We can say that we need something more complex, but at the core of the template files, we always have build style. So let's go to something more complex. I know that a lot of you had to deal with Python and packaging Python. I know there is Nico here that is part of the Python packaging team, and he's laughing because he knows that packaging Python is not easy, it's not trivial. The macros that we have been evolving for years and years, and they're very well crafted, but also they're powerful, flexible, and you need to know how to use them. So let's see how other distributions take this approach, how they package Python programs. So let's go start with the simplest approach, package build again. These just dependencies, we write the dependencies. The dependencies are just Python and then the package that we need, because there is only one version of Python that all the packages depend on. It's just bleeding edge. And this is not very interesting, it's just metadata, but let's go over to the second part, which is the most interesting one. I'm sorry if the code is too little. I will tell everything that is happening here. So again, we have the build phase. And somebody is going to look very weird at what is happening here, but we have a Python called just Python module build. No abstractions, nothing, no wrapper, just Python and build with a couple of arguments. And that is true for almost all the Python packages, because that is the approach of Arch Linux. Then we have the check, we call PyTest. And then we have the install phase, is called package here. We install files manually because there is no make install here. Usually there is not for Python packages. And we install them in pages, the documentation, the ZSH completion. Very simple approach. Keep it simple. It's their motto. Let's go to something that we are more familiar with. The Python RPM for the same package that we saw for Python card. It's a package that is a calendar in the terminal. Something very particular, but very easy also as well to package. First difference, we see build requires here with a macro instead of just saying Python pip, Python will. Why are we using a macro here? We're using a macro here just for the build required, not the runtime requirement, because we usually use multi-builds. So we build the same package for different Python versions. So we need the same dependencies for each Python version that we build. And the macro here, Python module, just expand. You see which kind of version we are building for, Python 3.13, Python 3.12. And then it says, OK, I need the Python 3.12 Unicode, Unidecode, and so on. Let's go to the build phases. Now we have a lot of macros, but this is very simple to reproduce because we can just say, oh, I need to use PyProject wheel. Oh, OK, how can I build a Python program? I can use this macro, and then it does everything. I don't need to know the specifics. I know that it's going to build it for multi-build, and it works. And this is one of the best things that we have with the RPM macros, because we can abstract a lot of things. We can have wrappers. We can standardize the way the Python packages are built. We can fix things later as well. We call PyProject wheel, which is the new way of building Python projects, by the way, because last years it has changed. It's not Python and build anymore. We have the install phase, PyProject install. Again, no repetition here, no manual install commands. And PyUnit test and so on. This is completely different than the Arch Linux approach. Personally, I like abstracting wrappers over just writing things manually. And let's go to one different ones. Excelbro package, same Python card. And this is also a distribution that uses multi-build, but not always, because sometimes, like for example, this is a binary. Do we really need multi-build for binaries? Usually we don't, so we can just build one package in one version. This is a source-based distribution, so everything is built in the host machine of the user. So the user probably will have a preference for Python version, maybe the latest, and we'll build Python card just for that version. So we disable multi-build. Here you can say that this is a library, the require PyPy, setup Py. These are libraries that we can use to reduce duplicated code, to abstract. Instead of using macros, we're using libraries, which is called xlibs. And this is very particular. We can have, we can say we are using setup tools. You can say that this package is a binary. We don't want multi-build. We don't want to use Python 2. These kind of things were there where Python 2 was still around, so we still have some kind of legacy code. And Blacklist 2 is the legacy code of xlibs. This is also important because we are going to talk about this later. We have the dependencies here. We have the group and then the name of the dependency. And we have something called Python APIs. So we are saying that every dependency will follow the same Python API, which is just the version, that we are building this package for. So we are using Python 3.12 for Python card. Then all the dependencies need to be installed for Python 3.12. This is also very powerful because we can just, even multi-build, this is the equivalent of Python module that we saw in the RPM macros. There is no build phase here, again, sorry. Again, there is no build phase here. We have the test one because we are doing something particular. We are using the config file. We have the install one because we are doing multiple things. But there is no build phase here because, again, by importing the setup Py xlib, we are importing the build phases function, the install phases function, and they will automatically be called and call Python, PyProject, whatever is the case for this package. They will call it, and we don't need to specify it again and again. This is also a very powerful and flexible approach because we can always change it. You can see here in the last function, src install, the install phase. We are calling setup Py src install, so we are defining a install phase, and we are calling the function for the setup Py. So we're still using the wrapper. Then we do a couple of things. We install the completion for ZSH shell. We install a documentation file as well. This is also something that I like a lot. It's wrappers. I think that duplication of the code is always something that, especially in packaging, is a lot of code, a lot of repetitions. Template file for card. A lot of metadata here as well, bash variables. We can see description, maintainers, license. OK. We can skip all of that, but the important part is the build style. Again, it's a different one than the one that we saw before. It's called Python free module. And we don't have any build phase again. This is defined in the Python free module. We'll install the Python program, we'll build it, and so on. We redefine the post-install because we need to install a couple of files later. So this is, again, we can change how it works afterwards, but we can still rely on the Python free module build style. So we've seen different approaches. We saw that we use RPM macros, very powerful. Where there is a distribution that just call programs, they build manually everything. There is distribution that have abstractions, Excelbro or Linux. I'm sure that many other distributions have abstractions. What is one issue that we have? How do we update a macro? Let's say that, for example, this macro was the original make install. The one that we saw before was make underscore install. This one is make install. And this is the deprecated one. In the past, this was the macro that was used. And it's still there because we cannot remove macros until all packages have been updated. And we cannot, it's not very easy to make sure that all packages have been updated to the new macros. So this is one of the caveats, because we need to update the macros, and doing it is duplicating the macros most of the times, or adding new macros. So we end up with maintaining a lot of macros for a lot of different things in the course of the years, especially if we consider that SUSE and openSUSE have been maintaining packages for years. We still maintain very old packages. I think that I saw the telnet package in openSUSE. So you can imagine how old is the telnet package. Maybe it was updated 10, 15 years ago. And we still maintain that. So it's not very easy. We can see also the comment there is the former make install analog. Let's do the same approach. How do other distributions like Exergo, how do they update their libraries, like the Xlibs? For Python in this case, they added a version of the API, which is default the two, because it's the new one. And they check, is this package using this param? Like, is this using blacklist? Oh, if it is using blacklist, then the version is of the API is still the 2. If it is not using blacklist, then it is the old API. We need to check and call different code. So we end up maintaining 2 different code paths with 2 different approaches, 2 different configs. Like in this case, the params might be different. And maybe PyProject just came out. We need a different one. We need a free API free version. So we add another code path. And this soon becomes free for very, very tedious, a lot of different paths. And also, we can think about Gentoo, for example, the E-class. They have the version inside the name file, and they have, I think last time I saw an E-class, a build, sorry. Last time I saw an ebuild, it was version 9. So they also have taken the same approach. They have been updating their packaging file over the course of the years, and they end up with version 9, something that we need to think of when we design our packaging, when we continue to maintain it. Let's see also one other specific edge case that often I encountered when I was packaging for Exergo. So in this case, this is a very simple program. It's a shell script. We just need to install it. And we have 2 different completion files that we need to install. One is bash, one is ZSH. There is libraries, there are Xlibs for that, require bash completion, require ZSH completion. And we import both of them. Both of them define a install phase function, but we need to call all of them. We cannot just let the package call the automated one, the default one. We need to go and specify ourselves the install phase, and we need to call all of the different Xlib functions for the install phase. So in this case, we are calling the bash completion. It will take the bash completion file and install it. Then it will call the ZSH. This soon becomes very hard to manage if you have more than 2 or 3 Xlibs. You may have 4 or 5 for maybe different shells, maybe different things that you need to do. You have many, many different Xlibs, and you need to define the order. You need to know which is the order that you need to call. What are they doing? This soon becomes very hard to write, and it could become a mess very, very soon. OK, this is a snippet. It's a part of the LibreOffice, the spec file. I was maintaining LibreOffice when I was a packager. This is a small snippet that was taken from there. So we have 2. Let's divide the file in 2. We have the first half and the second half. So in the first half, we can improve the code. We can just take everything and do a one-liner. And in the second half, there is one issue, one really big issue. So what can we do in the first half? Can you think of anything that we can do in the first half? Why is this code not very good? So first of all, if anybody is writing a code in something that is not Bash and is telling me that for getting a list of files from the system is appending every file to a string, it would be unacceptable for any programming language that is not Bash. If you tell me that you're doing that in Python, if you tell me you're doing that in C, I don't know what to do. I will just reject it. I will just reject the pull request without thinking. But in Bash, it's accepted. You can see that it's done very often. But this can be replaced by a very simple one-liner. We can just say files and use the globe. This is the globe expansion. And it's the exact same code. Let's go back. He used the globe here, and he does an iteration in a for. And for every file that we find, we just add it to the list of files. We can just do the same by using a globe like this. This is a very specific optimization that you can do in Bash, but you need to know and need to be aware of them to reduce the complexity of the code. It's very simple to write 4 lines, but then do it for all big packages like LibreOffice, you end up with a lot of bugs. Let's go now to the bug that we have in the second half. I think that many of you will have recognized what is the bug right now because it's very common. Every time you run a shell check on this kind of shell script, it will automatically tell you what is the bug. It's very common, but also very easy to miss. We need to use the array expansion when we have a Bash variable that contains many different values, like we have now. We have a list of files inside files. We cannot just say $ script and then files, because otherwise it won't get expanded properly. We need to use the correct syntax here. And though this is very common and very easy to fix, in a shell script that is very big, in packages that are very big, where we use a lot of shell script of Bash code, it's very easy to miss, and this can make the difference between a correct package and an incorrect one. I would like to argue that writing Bash is not easy. It's very easy to write it wrong, and very hard to review all the code there. So other things that can happen. We talked about build styles, and build styles are very cool, but they can easily become a very huge number of build styles, because we can have a build style for all Python 3 module, Python 3 binary, PyProject. Then we can have cargo or Meson for Rust programs, Meson for C, Meson for Python. We can have an exponential number of build styles, and this is also an issue, because we don't know where we are going to remove all these build styles. Maybe we need all of them. And now we need to maintain 150 build styles. Okay, that's maybe that might not be a big number, and then it becomes 200, and maybe more. Also, one other thing, this also applies to macros, to xlibs, to everything that regards packaging. Packaging is not trivial, and it takes works. We do our best to just duplicate all the code, to write wrappers, abstractions, but sometimes it's hard. The other issue that I find personally is that when we do packaging, the 90% is the same between all distributions. We were doing the Python 3 build. I think it's the same. We are installing configuration files. Maybe the location changes, okay, but many other things are the same across all distributions, and we repeat the code again and again and again. Think how many distributions there are. openSUSE is one of the biggest, but there are many more smaller ones. And they have to start and maintain 10,000 packages and repeating all the work that somebody else has already done. In a different format, yes. So let's see a couple of improvements. So we'll talk about the issues, the different approaches. Let's go over to what we can do, what can be done. So first of all, we have seen that Bash has a couple of issues. It's the most common shell script, is the one that is used everywhere. Everybody has a Bash shell installed on their system. But maybe there could be something that is still a shell script, but different approach. Maybe a shell script that helps us write code instead of making it simple to make it wrong. One of the shells that I found very simpler approach and less hard to write wrong code is oil shell. Now it's called oils for Unix, and this shell reminds a little bit of Python. As you can see here, this is the code for having the git prompt. And it's very similar to Python. There are a lot of checks, a lot of functions that we can use to actually write better code. This is one of the very different approaches that have been taken. There is a Python shell script, there is a Lua shell script. There are very different approaches, very different things. This is one of the various projects. Personally, I like it, but I think that it's open for discussion if we want to see if there is any alternative for Bash that we can use. I think that just discussing it is worthwhile. Another thing that we saw in the package build for Python card, we saw there were a lot of call to install. We call all files manually. I think if there is a package with 15, 20 files, we need to call install 20 times. And maybe we do the same in every distribution. So this is something that we can improve. We can remove this duplication of the code, of commands. And this is one of the approaches that I saw very viable. This is a restyle. It's a project that I was writing, and it defines a yum declarative file where you list all the files that you need to install. You can say, for example, this is wpepperd is another program in Rust. And you can say we can say this is the binary that this program has. These are the main pages. These are documentation. These are the completion. Then we put this file inside the repository. This is a file that should be maintained by the developers, by upstream. And we can just call restyle to install all the different files automatically. We can just say, this is our prefix, this is our bindir, this is our documentation directory. And restyle, we just install everything without duplicating all the commands. This is one of approaches. Again, I think that it's open for discussion if there is any other approach. Maybe the declarative file is not very good for installing files, for defining what we need. But there are many programs, many shell scripts that where using Makefile might be overkill. Also, Makefile syntax is something that is very hard to write, again, especially for installing. But this is another topic. Another approach, this is not one approach that I'm very familiar with, but I think that is very interesting. Many people have used that, have tried NixOS, and they've never got back to a traditional system. With NixOS, we can just define all the packages that we need. We can define all the configuration that we need, and NixOS will do everything automatically. We'll put up the machine up to what we have described in the configuration. We can just have the same configuration copied over to another machine, and NixOS will do the rest. And that is very powerful, and it's a very different approach. They have their own language here to define this configuration, and also this is a package. As you can see, we have the post install with the install command, and I think it's also worth to have a look at this. So another thing that maybe we can have some kind of improvement is having a distribution agnostic format. So instead of duplicating everything that the package needs, we can just extract some metadata, some commands that need to be called, some way of building the package, and maybe we can abstract that. We can just say that this is the base, and then every distribution can just import this new format and just remove the duplication of code. Maybe you can even get the developers, the upstream, to add more packaging, because most of the times when we package something, upstream doesn't really know what it's doing with packaging, what it means to package something. So sometimes they work not in our favor. They do things that is easier for them, but very harder for us. And sometimes it might be helpful to also get upstream on board. So thank you for your attention. Do you have any question? There is a question over there.
Have you looked into RPM's new declarative builds, which look kind of like a few of the examples?
Yes, I need to have a better look at that, but by the way that I saw, it was very, very interesting, very similar to the build style that we saw in the template file. This is something that somebody else was having the same issue, and they were doing work to fix it, so I'm very happy to have declarative builds in RPM.
And what's your opinion about dynamic build requires? Because that also simplifies spec files a lot. But the build service doesn't like them, I know.
Unfortunately, I need to look more into it, so I cannot give you a proper answer right now, but thank you for the question. I will look into that, and we can have a discussion about that.
Thanks.
Thank you. Okay, so if there are no more questions, thank you, everybody, and enjoy the rest of the openSUSE conference.